one of the section. Therefore, we also transfer to the diversity and inclusion. Okay, next. So far we have 4 missions to run through for this year, and we just launching our diversity and inclusion program last September. And this is the main key point that we are uphold legacy for women in energy. So it's part of the promote the leadership and also representation and recognition for women in SPE and also in the industry. And we also, as a platform, we support the diversity and inclusion to all members that would like to also share their experience and knowledge. And also, we would like to also members to be able to collaborate with us, because in the coming presentation, I will also share to you what kind of the program that we run through. So it's very welcome to contact me or other SPE Diversity Inclusion Committee for future collaboration. And the last is number 4, we are promoting the science, technology, engineering, and math in STEM across all the members in SPE Java section, and also and non-members also welcome. Okay, next. Okay, and this is the committee. There is 3 of us, the ladies. So there is Rahmi Shifa, will be also the moderator for this event, and also Agnes Tianovita. So as mentioned before, we are transformed from women in energy to this diversity and inclusion starting in 2021. Okay, next. And this is going to be our event for and through this program throughout the year. So we have the series of leadership talk that is part of the sharing session from the woman leader and also all member in the diversity section. And also we have women in STEM talk, or like today we have like a collaboration with TDG for the technical section. We also will have the woman of the quarter, so we promote some women in their field and also show to our social media platform about their stories. And also we also collaborate with the DNI SPE section, not only in Indonesia but also section in other international sections. And we also have a program called AG Takeover, that one of the person can share their stories and also like a Q&A for one day in our Instagram platform. Okay, next. And this that's the program that we have run through before, like Instagram Takeover is Rahmi share her life as a drilling engineer and also answer several questions throughout the day through the Instagram stories. And we have a series leadership talk that we invite the lead of the oil and gas company in Indonesia and also international, and also from Ibu Belevita. She was previously director of General Oil and Gas. And also we have a sharing session, just like a coffee talk, just share and also question and answer with those ladies also related to exploration Earth throughout the geoscience. Okay, I think that's all from me, and we will like to have a collaboration with you. So please don't hesitate to contact us if you would like to be present or be active to share your knowledge within this area. Thank you, Dian.
Okay, thank you, Mbak Nisa. So now we have a message from SPE membership. I will give the floor to Mas Ori. Mas Ori, the floor is yours. You can unmute, Mas.
Sorry. Okay. Okay. Voice. Okay. Okay, thanks, moderator. By the way, I'm still in the office, so I cannot put my mask down. Okay. Hello and good afternoon, everyone. Hope you all are staying healthy, right? Before you start this event, cementing, right? The event. And
Yes,
let me
Deepwater cementing, Mas Ori.
Okay. Let me introduce about SPE, especially in SPE Java. Before starting, my name is Casananda Oriandi, but you can call me Ori, and my colleague Thomas Jamal Jr. We are from membership division of SPE Java Section. The SPE is non-profit professional association with more than 140 members, and 145 countries are engaged in oil and gas exploration and production. SPE is key resource for technical knowledge, providing opportunities to exchange information in person, an online event, and training course, publication, and others resource. We will support professionals in the oil and gas exploration and production industry, young professionals, and students also pursuing related degrees with many benefits and opportunity, such as you can see in picture SPE online education. The most of SPE webinars are free members and include live presentation, training course, and so on. And then SPE Connect. This is SPE member can virtually communicate with others, exchange knowledge, and then talk about anything about petroleum. And then GPT, or Journal Petroleum Technology, it's like a SPE bookstore about oil and gas. And then One Petro is the SPE Professionals membership, give you 6 free SPE paper annually, along with your deeply pricing on SPE content found on onepetro.org. And of course, you can get discount if you are join conference, workshop, and course. In particularly Java section, you will additional benefits like free registration for Java SPE Java event for the whole years, like this. And then volunteer opportunities for SPE Java event, and then become a mentor or request a mentor, and then SPE over scholarship for student member. This is opportunity for the student, right? And then next one. Next slide, please.
Sorry, technical difficulty. Can you still see my slide?
Yes, but not. It's still freeze.
Okay, sorry.
Okay, good. So SPF, basically SPF, two types of membership, professional and student. If you are interested with us and want to get the benefits, you can register for 1 year membership. Especially for student, your payment will be sponsored by Chevron or CPI, and it's free. So, and what are you waiting for? Join us today by registering online in spe.org/join. And then you can see on YouTube for the tutorial how to join SPE as a student or as a professional. And if you any question, don't hesitate to contact us, right? Especially maybe if any professional members in here who want to renew the expired membership, or the student that graduate and want to convert to professional, you can contact us. Okay, that's all maybe.
Okay,
Thank you
very much.
everyone. Enjoy the event. Back to the moderator.
Thank you very much, Mas
Dian.
Ori.
Yeah.
So to complement the membership message, the SPE Java program also have this distinguished lecturer program. Yeah, it's back. This is provided by SPE International. You can look at the schedule in spe.org, DL schedule. These are the ones that will be visiting our Java section in November, December, and January. So please register if you're interested on the topics here from the distinguished lecturer. Yeah, how to register? You just need to go to this link. Yeah, and then you'll have this website open. Go to the See Your Sections DL events. And then once you enter that, you will have the list of available what do you call it, distinguished lecturers event that is available for the section, yeah, for the section that you registered. In this case, Java Indonesia section. So you can see the invitees here, and then you can see Indonesia Java section. You can choose which topic you're interested and then just register. And then you'll get the Zoom link directly into your email. All right. So without further ado, let me just one more time explain the house rules. So during the presentation, we will mute the participants. If you have any question, please type in your question in the Q&A session. Or raise your hand to ask directly during the Q&A session later on. Yeah, you may speak after permitted by the moderator. And last but not least, we will have a documentation later on, photo session after the presentation before the Q&A session. So please be prepared to turn on your camera. All right. So without further ado, I'll pass to Mbak Nisha to introduce the moderator and the speaker. The floor is yours, Mbak.
Okay, thank you, Dian. So our moderator for today is the Mbak Rahmi Shifa. She started her career as a drilling and engineer challenger in BP, and also become like a well site drilling engineer for around 10 months. And she also working in offshore as well. And now currently she is a drilling engineer starting in April 2020. So I will just pass the button to Rahmi to run the session. Rahmi, the floor is yours.
Okay, thank you, Vanessa, and hello and welcome, ladies and gentlemen, to our technical discussion group number 3, Deepwater Cementing Operations and Technology. Also, warm welcome to our honorable speaker, Mbak Cinto Azwar, who will facilitate and share her knowledge and experiences on today's session. Before we deep dive into the topic, let me reintroduce myself first. My name is Rahmi. I'll be your moderator today. I'm currently working as a drilling engineer for BP Indonesia and have been in the industry for 5 years. I'm also one of the Diversity and Inclusion Committee in SPE Java Section. And today we have a special speaker, which is Mbak Cinto Azwar. She has 20 years of oil and gas industry experience, specializing in well integrity and cementing technology, with vast experience in well services and pumping operations. She's been working with Schlumberger in a various positions, which is mainly located in offshore and deepwater location. And also she's been doing some, she's been exposed to some operation in land, desert, and swamp operation. Mbak Cinto kicked off her career in New Mexico, USA. Then she moved to Balikpapan, where she was involved in deepwater cementing operation. And prior to her current role, she spent more than 3 years with the cementing deepwater peer review team as cementing deepwater specialist. And now Mbak Cinto is currently working as the cementing domain champion for Asia region based in Jakarta. On to the topic, which is deep water, very interesting. So deep water is one of the most technically and logistically challenging environment for cementing operation. And understanding these technical challenges is the key to designing the optimized cement slurries that meet the deep water specification. Deepwater operation surely requires special cementing knowledge, technologies, services, and products to ensure zonal isolation and long-term wellbore integrity. And without further ado, I'll hand it over to Mbak Cinto to present her materials. And during the presentation, should you have any questions, please feel free to chat your question in the chat box on the site. Or if you want to ask it directly, please raise your hands and we'll let you ask to Mbak Cinto directly. Okay, so go ahead, Mbak Cinto, time is yours.
Thank you. Let me share my screen. Can you see my screen?
Yes.
Barami? Okay. Okay. Hold on. Some technical problem here. Hold on. I need to move the display. Hold on.
No worries, but take your time.
Okay. Good afternoon, everyone. First of all, I would like to thank the SPE Java Indonesia Section for having me here in the technical discussion group. Thank you, Rahmi, for the introduction and for being the moderator today with Mbak Nisa. Thank you for all the participants that are here joining this discussion on your busy Friday afternoon. So today we will talk about the water cementing operation and technology. To start with, we'll talk about the definition. What is actually deep water? So in the industrial, the general definition, usually they will start categorizing the operation as deep water when it's water depth above 1,500 feet. When it is above 5,000 feet, it is called as ultra deep water. So the water depth that I'm talking about here is the one from the mean sea level down to the seabed. So that's the water depth that we are measuring. So different companies, they are using different standard or definition when at which point they're categorizing it as a deep water operation. And I know one of the service company, they're using definition of deep water from 500 feet, for example. So that's already categorized as deep water. Reason being because from water depth of 500 feet, we will start usually having the risk of having shallow flow hazard at this point. Regardless any kind of water depth, once the operation is using subsea BOP, subsea wellhead, that's also already categorized as a deep water operation, used by other companies, some company, because once we have the subsea BOP installed or used, even in a jackup operation, for example, like only like very shallow water using the jackup rig. But once we are converting to subsea BOP, the whole set of equipment that need to be utilized in the operation is already changed to a deep water equipment system, right? So, so how is deep water rig different from conventional shallow water or land rigs? So, as you can see in the picture here, the rig is not attached to the earth, so they're floating, and it has the mooring system or dynamic positioning system. It uses thrusters at the underwater to actively keep the floating structure stationary in the position that it has to be there on the same coordinate at all time. Regardless the feedback that the rig is getting from the wind, the waves, and the sea current. So those thrusters or dynamic positioning system is there to maintain the same coordinate and position at all time. So that's the huge difference than the jackup rig, for example. And then it has a subsea BOP, the one that I mentioned before. BOP is blowout preventer, and it's installed usually in the land. It's, of course, you can see it is there in the surface, but in the deep water operation, it's there in the subsea down underwater, right? It has riser, so the white string you can see in the picture there is what we call drilling riser. It's a steel pipe that connects the offshore well down at the seabed to the drilling unit or to the rig. It is big in size. It is usually 19 to 21 inch, and it has buoyancy modules. So if you go to the any deep water rig, you see big pipes, white, with some foam around it. That's the riser that is not yet run or installed, right? And it has usually the rig has a very big variable deck load capacity because it is usually handling remote operation. Another unique thing is it's utilizing specialized equipment. For example, the ROV, a remote operated vehicle, that the one that they operate underwater is like with the robotic arm. It's used, to help the operation in subsea, either to open and close the valve, or basically there with the camera, with some lighting, monitoring, see what's going on at the subsea level, right? So that's used in the water operation usually. And it also comes with a very high daily rig rate to compare with the rest of the different type of the rigs, which is not the deep water, right? Yeah, so that's the riser that I was talking about. Okay, next one. Do you see this? How do I move this one? Do you see this the one on top, Rahmi, on the screen on my slide?
Mature deep water basins, is that one?
Oh, no, but do you see the control, the white control? No, so it's just me because it's blocking my view.
Oh, okay.
It's from the Zoom. Okay, no problem. So next slide is basically, I'm going to talk about right now how many active deep water rigs operating globally, right? Just to give you an insight of what's going on right now, when October 2021, this is the very recent number. So the numbers I divided into two different type of rigs. So we have drill ship and the semi-sub, and then different type of the rig capacity based on the water depth capacity. So you can see there, with the drill ship, we have around 55 now active operating, and then the semi-sub as the remaining. And hold on. And then we have 7 semi-sub and 18 drill ship, which is under construction now or major build rebuild. So not very impressive number. Actually is very sad number, because if you compare it, I have also the numbers from back then, from 2011. This is the table that with the number from 2011. You can see the drill ship, we have 46, but the semi-sub, it was more than 150 rigs operating. Drill ship at that time was starting to build up more in quantity. And you can see that at that time, when I got this number, they were also building up a new build a semi-submersible rig at 56 and 30 drill ship at that time was under construction. So 2011 is when the activities start to pick up quickly after the 2010 very short-term downturn, and then we are quickly picking up, and especially after the Macondo incident, we are basically raising up on activity, including and mostly on the water as well. This slide is another one about just a very similar message. It's just to let you know on the hold on, I'm messing around again with this view of the, now it's blocking my view. About regional activity by the rig type, right? So again, it's the same number, but I just distributed into the different area in the world between drill ship and the semi-sub. Okay, now rig rate, right? So we've been talking about all this high tech and then all the capacity in operating. So we would like to know, of course, and this is a published rate, so it is not confidential. So that you can see in the screen, this is the rig rate spread per asset type, right? There is, and this is the current one right now. And you can see there is a big number both in semi-sub and drill ship. Semi-sub is the one on the left, and then the drill ship on the right. And the drill ship, you can see we have 580 per day, K per day. But there was just, there was the contract that was signed before or prior to the COVID downturn. So, but mainly in the number of the rig rate is a lot lower than that, and then the current average of the rig rate in the water, both for semi-sub and drill ship, are the same, which is at 250K per day. So, and how is this to compare with 2013 or 2011 onwards, before the 2015 downturn, right? So back then, 2013, the Deepwater rig day rates in the Gulf of Mexico, in average, it was 410K per day. And in Africa, it was reaching 515K per day. And just want to let you know, the picture on the right, this is a vintage rig named Platinum Explorer. Is the drill ship that enters new build, enters India water 2012, and I was there providing the services in this rig. And back then, it was the most recent generation of the drill ship, one of the 5-star rig in the market at that moment. It has dual derrick, all autonomous thing, system in the rig. It could operate up to 10,000 feet of water depth. And back then, it was at the highest one, the rate was 590K per day, just for the asset, just for the rig itself, right? So if we're talking about operating rate, then you will see a lot bigger number, right? Because it means we are adding all the facility, all the operation and services that is included into the asset rate to get the operation going. So for example, the vessel, the helicopter, the personnel, the service provider that's already on the rig, and then the rig is operating. That number back then, 2012, could easily reach $1 million per year, per day, easily, right? So that was actually the real number. And yeah, so, but right now that's not happening. We're still not fully, back to the same rate again after the two big downturn, right? So those high operational costs is basically nothing if we are comparing with the cost of doing it wrong, right? So this picture is coming from the 2010 disaster, the Macondo incident, the Deepwater Horizon incident. I believe everyone in the, everyone here have heard about this. It's exploded and killing 11 people, releasing 200 million gallons of oil to the sea in the Gulf of Mexico. And last data, the operator that need to pay for paying the criminal civil penalties, natural resources damages, cleanup costs, is easily taking to right now is 16 billion US dollar easily. So for those of you who have not seen the movie, go and watch this one. Since we are all working, I'm assuming we are working in the energy industry, right? It's very interesting because all the technical term are there, and it feels like it's so relevant with your life, especially if you've been working in the water rig. It's very interesting. Then all the detail. You'll find out what's going on with a lot of drama, of course, additional. These two slides, I'm just gonna go quickly, just to show you the world record of water depth that we've been operating. Again, this is the 2012 data when I was still I was in India. The world record at that time, and I believe until now, of water depth is at 2,100 meter water depth, drilled by Transocean rig DDKG2 for our operator Reliance. And this is the world record of the well depth in the deep water operation, drilled by Deepwater Horizon 2009 up to 10,680 meters of the depth of the well. Yeah. And of course, is involving high pressure at the bottom hole pressure. Okay, so up to this point, any question?
But Cinto, I think it's very interesting the data you presented, yeah. Between the 2011 and 2021, it seems to me that whether, even though the numbers of rigs are reducing, but they're kind of moving towards the deep water. Does that have to do with the formation availability? I mean, the more deeper we drill every year because of the shallow ones are already drilled, or do you have any opinion about that?
Yes, so basically they wanted to go, and of course they wanted to reach the biggest reserve available there is, right? And the more the market is higher, the more higher the bigger is the demand, then they will calculate and economically will be profitable. They will go deeper, right? And therefore 2011 onwards until the downturn, everyone in the industry is basically investing a lot, and because they wanted to facilitate this ambitious by the operator to reach to that reserve and then produce, right? So that's why the drilling company, the rig company, they're investing, they're building so many rigs, the water is at the moment, yeah. So
probably because the price is also pretty similar with the semi-submersible and the drill ship as well, yeah.
Between the semi-sub and the drill ship?
Yeah, I mean, it's getting cheaper, right? The price, the rig spread rate.
Right now?
Yeah.
Yeah, because of the, yes. And then the number of rigs are gone, right? Because less demand, because there's no demand, and it's just operating too expensive just to get to try to produce the oil that is a lot cheaper than what is supposed to be. The ideal situation at the time when people are drilling a lot in the water was at $100 per barrel, right? Mm-hmm. So when it's going down, they're just also chopping off their the water rig, especially the old one, retired in the junkyard.
Interesting. And we have a question from Mbak Nisha. What about Indonesia Deepwater, especially on the eastern of Indonesia? The last time we had Chevron IDD, it got released. And what is your views regarding this?
The Chevron IDD. Well, again, is of course directly related to economical, Rahmi, right? So Nisha, the Chevron IDD is they plan to drill and develop their field more after the West Seno, and then but it's get delayed, and in with the 2020 downturn, it's going to be difficult. I think I don't see, but we have people here in this call, kayak Mas Bayu. They are going to start up their deepwater operation, right? So some operator that they see potential, because now, of course, we see now the oil price is increasing, right? It is going to the right direction, because for us working in the industry, and then yeah. So and then this there are investor or this operator that have the location in the water in Indonesia. They are starting to drill again. I know 2 operators are starting beginning of the year, and some of them are actually attending this call. So yeah, so we are excited to hopefully we are back to 2012.
Yeah, fingers crossed, Mbak Cinto. Looking good so far.
Okay. Continue, Rahmi, yeah?
Yeah, go ahead, Mbak Cinto.
All right, so now we go to overview of cementing services in the water operation, yeah? So yeah, it is a mature emerging market. It's nothing new. So we all know the challenges. We all the industry already have the right technology and all the mitigation plan and the solution for the challenges, right? So the cementing challenge, all these challenges is becoming technical drivers in the water. So all the challenges that we see, for example, the operational cost. So then therefore we want to, reduce number of standby or waiting. That's why even the rig, they comes with dual derrick now. So when they're still drilling, they already start running casing. Right, Rahmi? So I think you've seen this before, right? In drill ship, it's really possible now. And then what else? So operational cost is one of the challenges that we always, or everyone in the industry will find a solution to lower down the cost. There is a Cello hazard challenges, which is the water flows, gas hydrates. And then we are dealing with low temperature environment here, because the seabed temperature, it could be as low as 2 degrees, or even 0 or 1. Usually it's around 2 to 4 in Indonesia. I've seen 4 for water depth more than 1,200 meters. Deal with 2 degrees as well. This is at seabed, so it means your fluid that you pump down hole is going to expose to this cooling down temperature until it reach the formation. Then it start building up temperature based on the formation temperature gradient, right? So you have to design your fluid, your cement based on this, which is very challenging. The well complexity, narrow annuli, which then consequences that you will have losses because of the high ECD impacted in the narrow annuli. The job size, you won't see this kind of this huge volume that we are pumping in deep water in land operation, for example. Like easily we are pumping in one job 1,000 to 2,000 barrel of slurry for top section. And the biggest one I've seen, I will also present to you in this technical discussion. We pump 4,000 barrel of slurry in the top section. So it's 12 hours operation on pumping, continuously pumping. very, very excited, very challenging because it's so big, right? And then of course we have low circulation. Some area they have always, they have a massive salt zone in Angola, for example. They have flowing tar, something that again challenging, high pressure. So we have the Deepwater HPST location. The unit requirement, again, 12 hours pumping, you need to have a lot of redundancy in your equipment. It has to be reliable. So it's different set of equipment that we have installed on this rig, right? You have what they call an annular pressure build-up. Is also only happen in the water set of well. And then there's a modeling, temperature modeling that has to be accurate. The testing also is different than the rest of environment. So now we go with the first challenge, shallow flow hazard. In the water areas, we often find a heavily water saturated or high water pressure formation. Geopressure sand bodies usually happen or found between, on the top section, between 600 feet to 2,500 below the mud line. And there are 3 types of shallow flow hazard. There is water, the most common one, water flowing once you open up the hole, gas or hydrates, and then formation fines. It's commonly caused by high overpressure sand at the top section, and then if let's say we drill into one body that is isolated, probably the result is not too bad. You can handle it while you're drilling, right? But if the sand body are connected to different section, and then drilling into one of them can cause the water to flow or the gas to come to the surface. So and that can cause extensive damage to the borehole and to the well site itself, right? So that's how it get becoming a real hazard here in the water. So how does the shallow water flow looks like downhole? So I have a video here showing the shallow water flow, one example at the seabed. The movie was taken by the ROV on the seafloor. Let me just play the video. Is the video without sound, yeah? Okay, so you can see that from the port, the low pressure wellhead, I think. It's the water is just flowing because we cannot control it. We fail to control it, right? So this giving us a safety environmental risk. This flow can occur while drilling the riser section, the top section. If we do not mitigate properly, also it can occur during the cementing job. And if it's happening during cementing job, or after post placement of the cementing job, then you will lose the isolation that you are expecting to get from the cementing job, right? So, and then the erosion of the seabed and drill hole due to the continuous flowing of the water, this can weaken the structural support at the seabed on the conductor casing, reducing or failing integrity of the BOP and the riser. So you can, it's very difficult to remediate this or to fix this. You can easily lose your well because of this. So it's really important and crucial to be ready and have a good subsurface assessment, so you know what kind of if you do have this kind of risk. If you are drilling an exploration wildcat well and you have a doubt, my suggestion is do not take any chance, because really once we have this flow, it's very difficult to remediate, right? So it's very high cost risk. The next one is hydrates or a gas hydrate. So what is gas hydrate? It is a solid ice-like compound of natural gas and water. It is formed in high pressure and low temperature condition. And how do we destabilize the gas hydrate? So if let's say we know from the subsurface reading that in this section, on the top section, we going to expect to have a gas hydrate bearing zone, then we need to put different mitigation. We need to make sure that that we won't destabilize, or we move to different area that there is no hydrate. Yeah, that's the easy one. But if it's not possible, you have to go through that part, and there is a way to make sure that it's not destabilized. So it will destabilize when the pressure is decreased or temperature is increased. And the gas hydrate near the seabed, for example, will be exposed with the drilling fluid, which having a higher temperature, of course. And then cement hydration, when we pump the cement will also release heat of hydration, and that will also destabilize the gas hydrates that we have in the formation, right? So those sort of things that we need to avoid. The consequences is so you can see this form of solid ice, right? So it can go to anywhere of your equipment downhole in the subsea, including your production pipe. So this risk is not just existing in the drilling phase, but it's also there in the production phase. I've seen the picture, and I'll show it to you, of the solid gas hydrates blocking the whole pipe of production pipe, right? So consequences is also bad. Will plug your production tubing, blocks your BOP. So there are a few prevention or mitigation plan that we can put here for drilling fluid. For example, you need to put a proper selection of a mud type with addition of the chemical to make sure that the mud is going to keep cool and will be at the very low temperature at all time. So like by adding glycol or salt. For cementing, we need to also choose the right type of slurry system. The cement that producing a lower heat of hydration. Right, this typical cement is basically have a lot lower concentration of cement per volume of slurry. So there is a type of cement that has there is engineered optimized particle size of distribution that has a small cementitious material content, and this one will help you because it's releasing very low heat of hydration. This I saw you another video of hydrates risk. Which already happened in this video, and it's huge. It's forming huge block of ice and still flowing gas to the surface. Yeah. So yeah, short video, no audio. You can see here. Okay, and this is the production tubing that is already plugged with the hydrates. So, okay, continue, Rahmi.
Yeah, so we have an interesting question on the chat box from Pak Priyo Utomo. Quick question to Ms. Cinto Azwar. From the 2010 Deepwater Horizon incident reports, BP had been told that weeks before that the explosion that the cement slurry that will be used for the well was unstable. Halliburton, that was responsible for the cementing process, reportedly carried out 2 tests of the mixture, which indicated that the foam slurry was unstable. Later, was Schlumberger supposed to run the CBL or other Q&A tools, quality tools, quality assessment tools, showing critical cementing conditions? Could you elaborate more why BP site engineers just paid no proper attention to such seemingly unsafe situations? that finally led to the huge incident, and it comment. It's a bit awkward.
Bapak, Mbak Rami works in DP. No, it's okay.
Yeah, you go ahead first. I probably will
Yeah, I
have
try
some
to
additional
touch
comments
it
for
at a
this.
high level, only, Mbak Rami. So, so yeah, so you know everything in detail. It means you know it started it. So then at least it's a good thing, because then you know how important to you know, do a cement and design and execute the cement job the right thing at the first time, right? So there are a lot of standard and parameters that we're going to go through also in this slide, and specific cement properties that we should follow and make sure that it is going to give you a stable and avoid any, or you know, to give you a long-term well integrity basically. So what happened in BP is sorry, in the Mokondo incident, I think there are so many compelling events, like you know, going towards to the incident is not just one. Although yes, the first thing happened was because we lost the integrity of the well because of the cement at the liner was leak, right? But then after that, basically before, I mean, actually, if we do have that situation, we have another barrier, but which accidentally also fail, right? Unfortunately, also fail. So, but in terms of cement properties and standards, it's not that the service provider doesn't know what to do on, or the operator did not check it, right? But I think there are many in that part. There's some either a human error as well as a standard that is not so strict at that moment. There's so many changes done in the BP, in that company internally, a huge change that making it everything now so strict, and including API. They right away they form this committee to completely change and make sure that everything is standardized and has to be followed. The shells becoming should, and it's becoming a must. The recommended procedure is becoming a standard. This is done right after the part of the investigation. I think that's all. Rami, you wanted to add?
Yeah, Pak Priyo, it's an interesting question and actually a big lesson learned from us. We internal BP ourselves, we always conduct like not a memorial, but like you may call it anniversary, but actually anniversary to review the lessons learned, especially each year towards what happened in the Macondo incident. And actually it's not, well, it's probably a bit biased, but I wouldn't say that we completely ignored the situation. We did. I'm trying to remember what happened on the lessons learned that we regularly discuss. But the point is, it's kind of cheese crater where you have multiple barriers that finally cross or finally just fail in a 1 in a million incidents. So the first one, it surely happened because of the unstable cement slurry. To be honest, I wasn't involved in that operation, so I wasn't really clear about that, what type of slurry or what type of lab test that conducted back then. But then we pressure tested, positive pressure test the liner, which turned out okay. And we also performed the negative pressure test where we bleed off some pressure from the wellbore. However, the error here, because we fill out the riser and kill line using the lost circulation material, it's kind of plugging onto the kill line. So when we perform the negative pressure test, we didn't actually see a buildup on the kill line. So that's why it's a confirmation bias from within the team. And we thought that the liner or the cement was okay back then. But yeah, unfortunately, bad things happen. and the BOP was too late to be closed back then. So the kick was already inside the BOP and the riser system. So it wasn't possible for us to close anymore. So yeah, and it's correct what Mbak Cinto mentioned. We did learn so much from it. We paid so many technical specialists. We recruited so many technical specialists, and we totally rebuild our practices. And probably Mbak Cinto, as one of the contractors, and probably others from the other contractors notice or know that BP Nol has probably one of the most stricted BP practices, which is actually stronger than the API itself. So hopefully will prevent any more bad things happen in the future.
Exactly. Yeah. BP does have a cementing manual on its own, and it's very strict.
Yeah.
Okay. So we go back to the slide. This is just again to summarize the challenges in the water impacting the cementing job. We talk about shallow water flow, and then the cold temperature challenges, while the need of getting high compressive strength development. And here I wanted to mention about the narrow pore and frac pressure window. Therefore, for cementing, low density cement system require for shallow casing string. And then the low circulation is also there due to this narrow window, right? So again, here I'm going to quickly just explain before we go to the cementing solution. How do we actually see, the challenge when the slurry can be, invaded by the gas or the fluid at any point during the hydration period. So I'm going to explain the 4 phases in the setting process of the cement slurry. It is important to know and understand at which point in these 4 phases that the slurry properties and what slurry properties that we need to achieve in designing the cement slurry in order to mitigate any fluid or gas migration into the system, right, in the annulus. So the x-axis is the time, the y is the pressure, and then you see the phase 1 is when the slurry is fully liquid. This is what we pump down whole, and the phase 2 is when it start having the early gelation. And then as the slurry start to set, so you can see the line of the hydrostatic pressure line here, the blue line. You see, and the early gelation is start decreasing hydrostatic, because the slurry start to set, it will start to carry its own weight. This result in less transmitted hydrostatic pressure to the annulus, right? And it keep dropping down until to the point it's becoming the same to the pore pressure that we have, right? And then once we have the same pressure as the pore pressure, this is becoming the critical. This is when the critical hydration period starts, and this is basically in the phase E of the setting, which is the hydration period, right? And then it stop completely to be able to the critical hydration period basically stop completely when the cement is already set into fully concrete rock matrix, right? So transmitted hydrostatic pressure keeps on dropping, and after amount of time, the cement matrix when it's set, is considered to be impermeable matrix. So then once we know this process, right? So we know that this period in the 2 red dot is basically the one that is very critical, then the one that we need to monitor and keeping it as short as possible. Okay, and then the temperature, now about the temperature, the low temperature, right? The temperature plot on the right Okay, so in the chart that you can see is mean sea level and then mud line. Okay, and then the first graph is the sea current velocity, and then the next one is the temperature profile. Right, this temperature profile, this curve, this is a very classical temperature profile that you will find in most of the deep water operation, right? There are like 3 different slot here. Like the first one, the first 200 feet of water depth is basically a rapid cooling down due to the lower water. It's the water temperature that's going lower, and it's just rapidly going down. And then it started to cooling, and then the effect, part where the gradient of the cooling will be decreasing a little bit. And then the zone, and then the next zone is basically when it's just going to straight until it reaches the temperature at the seabed. So basically at one point in the water, in the sea, from some point, it's just going to be the same temperature until the seabed, right? So this shape is the normal one that you will see in the water. So just showing you some plot from different area of sea temperature against the water depth from different area, different time around the world. So this is from Indonesia is also there. We plotted there. You can see Gulf of Mexico, Brazil, and Japan. This is from the real measurement, right? Next is the one about the narrow margin, right? So there's a big effect on the water depth on the fracture gradient. The chart here is a fracture equivalent, a formation fracture in PPG, in equivalent mud weight, versus the water depth, or so versus the water depth for the water. But we also plot the land here just for you to compare. So this is how, so the land usually from the first section, they will what do you call it? They will start with 12 ppg equivalent mud weight. But for deep water, at the seabed, we will start around very close to water water density, or ECD. Yeah. So, and then so that part is already narrow by itself, and the deeper your water depth is, usually the lower your fracture gradient, because this is all unconsolidated sand at the top of the section. Yeah. And this is just a measurement, actual measurement or comparison from Gulf of Mexico between the jackup or self-operation to the deep water one, right? So this is how narrow a window that we are allowed to operate, right? From the drilling, from the opening up the seabed, the earth at the mud line, until we reach TD. The envelope that is available for us to drill safely is very narrow. If you compare to jackup operation here on the left, it's very big, right? So that's why you can compare, especially in the top section. You have usually bigger window to operate, and then once you reach to the production zone, is narrowing down. But in the water, you start very narrow, and then you probably stay narrow until the end. So, because once you reach the reservoir section, usually you will get the high formation pressure also. So with that said, of course, we're gonna expect a very complicated, complex well design. This is one of the example. So reason why we must go this complex well construction design, this is because of all those challenges that I just mentioned to you, right? The more you're adding number of strings So over here, you can see we have 8 strings, and this is typical. It's not uncommon. You go to any well in Gulf of Mexico, you will see something like this. So 8 strings, 1 contingency liner. They also have salt, especially also in Africa. They have flowing tar. Of course, low temperature, Cello Hydrate. What else they have? We have, due to a lot of casing and liner, different sizes, and we are dealing with narrow annular to when we are cementing the section. And of course, they also have a high pressure zone at the bottom if we are dealing with in the high pressure deep water well. So what kind of slurry properties that we are aiming to for these challenges? So density is giving direct impact, of course. So we want to design it at low density appropriately, accordingly to the envelope given to us. Although it's lightweight, but it has to be having early compressive strength development, because we don't want to, to ask the rig to wait for a long time until the cement is set, because then you are increasing the operational cost. So lightweight slurry with high compressive strength development should be coming with high solid volume fraction. Then if you are an operator, you can ask if the slurry that's proposed by the service company has the lower heat of hydration. If you do have that risk of having a hydrate gas bearing in the top section, which is, just ask if the slurry has a less cementitious material per volume of the slurry, for example. And usually it always have to come with improved set enhancer. So special additive is there for the water, which is not required in land operation. So you will see that there's a difference if you are evaluating, if you are from the operator and evaluating the slurry recipe. Yeah? Free fluid in the slurry, and then because of the shallow flow hazard, the gas migration risk, we will design the fluid loss to be very low, below 50 mils per 30 minutes in API standard. We want to have a very short period of a critical hydration. There's a way also to measure this in the lab, and the industrial standard use is 45 minutes. Or below 45 minutes for the high risk of a gas migration. So it's good to have also low circulation material in the slurry. And of course, if there is a properties that can help ensuring long-term well integrity, let's say if you need to, if it's a very high gas risk content, you can ask if the service provider can provide a self-healing or a spending agent, because this type will help you in ensuring the long-term well integrity. Just quickly on the typical cement slurry. So OPSD is the engineer optimized particle size distribution system. Because of the water depth, make sure that the blend or the lightweight blend is competent to hold the hydrostatic due to the very big water depth. So the rating of the glass beads that is blended in the lightweight has to be high pressure, high rated. SPF supposed to be high as well, because we want the compressive strength to start developing very early. So this is the typical additive you can see. There is anti-foam, low temperature dispersion, low temperature set enhancer. So the same set you will see in any deep water. There's conventional system, and then there is foam system as well. And this is all designed for a Cello water flow. Okay. Okay, so we also need to practice the regular cementing practice, which is ensuring good mud removal, casing good casing stand-off centralization. So yeah, the good mud removal means like if we don't want to have the casing, you know, sticking up to one side of the well, for example. Therefore, when we pump the slurry, we cannot remove the whole mud completely. Then it will, if we still have the mud left in the hole, then our cement slurry will then get contaminated with the mud. Then it will not get all the properties that you wanted to have as per what we designed in the lab, for example, right? So we want to avoid that. We want to avoid having channeling. All of these, you need to run enough centralizer, run with the simulation, the software simulation. All the service providers have their software now, and simulate and then see where you need to put your centralizer at how many quantity, right? So selecting the right slurry is not it's not just about the fancy slurry, but it's also the rest of the practice of the cement placement. Okay. And then you need to have enough cement volume. So big excess, usually we are expecting on the top section of the hole of any Deepwater well. So typical annular excess in conductor casing is 200 to 300%. Surface, usually we are taking 100 to 200% open hole excess, yeah? So means on top of the hole opener size or the bit size, you put additional access here. Why do we need this big? Because the top section is very unconsolidated, and then plus we are opening the hole with a very big bit or big hole opener, so it is going to create this big. And then also we want to make sure that the slurry is going to reach the surface to the seabed. The whole thing from the chute to the seabed has to be covered by the cement, because we need this slurry concrete to hold the load of the wellhead, the BOP that's going to latch on the surface casing, for example. So it's very important to pump enough volume. It is big, and then to reach the isolation, yeah. Okay, so this is more technical calculation on the same way on the effort on minimizing the critical hydration period to its best. So there is a given formulation to calculate the static gel strength where we start with our critical hydration period at any point in the hole. Right? So we calculate this and then we double check against our slurry properties. Okay, so do we have question or?
Actually, I'm curious about something. Like, how do you balance between the light slurry to avoid losses versus the good mud removal or zonal isolation to prevent the gas, water, and oil flowing? And also, I understand that the cement is probably one of the best loss cure materials, but how do you make sure that the cement will seal the weak formation first before the circulating ECD actually breaks the formation further?
Okay, so let me just, and the first one is how do we balance lightweight and
good mud removal?
The good mud removal, right? So the important thing is your mud is always going to be lower, if not the same density as your slurry. Okay, at least you for the top section, for example, and it's always vertical. The maximum, you cannot have angle on the top section at the seabed, for example, yeah, because then you will be having problem on latching your BOP. So it's not going to be any angle. So the top section is mostly for conductor is going to be all vertical and maybe a little bit deviated on the surface section. So those two sections, if we have just at least 0.5 ppg different, or sometimes even I have a case where I have to design the slurry to be at the same density as the mud. The density hierarchy is basically on the vertical section is giving a big impact on mud removal. And then we're talking about a big hole, right? So if I manage to put 0.5 or 1 ppg heavier slurry to compare to the mud, I will it will make sure that the mud will be removed. Most of the time it's going to be like that, because your mud on the top section is also not going to be a difficult mud. It's not going to be oil-based mud, definitely is not. So it's not going to be that heavy. So if they put a pet mud, then it could probably viscose, but we usually will ask if there is no shallow water hazard. We will ask if they can, circulate with seawater first, or chemical wash, or whatever wash ahead, just to try to dilute a little and then try to clean, and then followed by the spacer, and then the slurry. So that part is usually is not going to be difficult, Rahmi. In the vertical well, yeah, because the density hierarchy is going to help a lot.
Okay, Mbak.
Yeah.
Thank you.
Anything else? No.
Oh yeah. There's another question from Nisha. You mentioned about the 12 hours continuously pumping.
Yes.
Right? And amount of cementing pumping is also huge. How to plan the logistic, and have you experienced any challenges?
Yes. So this is very good one. The photo that I saw you, one of our rig in India, DTKG1. I don't know if you remember that big drill ship photo. That's actually from my own collection. That's the rig that we also operated in India. It was drilling 3 wells in Andaman and Nicobar Island, very close to Andaman Nicobar Island in India. And while that's very far away, while the supporting base was in Kakinada, is basically 3 days boat turnaround. So for us to send cement to Andaman, it takes 3 days turnaround. It means, yeah. So one way 3 days. So basically, yeah. And then they have only two vessels supporting. So yeah, it's logistic basically. It's a big challenge in the water, especially if you are very, very remote, like for example, that case. In Indonesia so far, I think we have like 6-8 hours. Is still within the reach. And nowadays, because the vessel, I think also vessel is very comes with the low rate. I've seen one rig supported by 3-4 vessels. So it's very, actually we're taking it for granted right now. Before, because everything is so expensive, we have to stretch and have so many limitations. So how do we manage that? So we fill up all the vessels. So it's just a whole management of logistics, right? Not just from the service provider, it's also from the operator side. So the more planning and detailing and process that you take, the more better you are. Because once you spot the well, you're basically done. The whole process is basically designing the operation itself, right? So was that the question? Yeah, the question on the logistic, right?
Yeah. And challenges, but yeah, that I think that answers the question.
Okay. So now Mbak Nisa is asking about the job size, the big one. Yeah, so I can just go directly to this one. This is a lesson learned relating to the biggest job, I think, in our company. have been performed this so far. This is from, I don't think it's a secret. This is a BP Thunder Horse well. It was drilled 2006. And we executed. So let's just talk about the well design, right? Water depth is 1,700 meters. And then the big job is on the 20-inch casing, the surface section is set at 10,400. You see the casing point here, 10,400. Your seabed is here, deduct, yeah, minus 1,700, right? So, and then we have salt as well. And then we had a Cello water flow zone at 8,200 formation section. And then 4 degrees C at the seabed temperature, so low temperature as well, right? So in this job, this is the job that we are pumping 4,435 barrel of slurry of that engineered particle size distribution, which comes with the low heat of hydration. The job preparation, as I mentioned, it's a good point that you brought about the remote operation and the big volume job. So the whole planning of this job is done a year before. So this is a lot of engineering in front, which is a year before for this case. It's related, it's involving 6 different slurry because that long section, right? We want to have different setting time on each slurry in different layer. Otherwise, if the whole thing comes with 20-hour setting times, then we will have a much longer wait on cement times until it start to develop the gel, the compressive strength, right? So although it's one type of slurry density, it comes with different type of setting time up to from the casing suit to the seabed, right? So extra people is required. So bear in mind in the back then in a deep water operation, especially in Gulf of Mexico where everything is very mature, the cementing personnel on board is only 2 maximum. Sometimes only 1 because of the POB limitation as personnel on board quantity limitation also. And plus it's just not required because all the installation is fixed. Your pipe, everything, you don't have to rig down, rig up. So everything is fixed. You have your rig crew to help you to mix if you need to move your additive here and there, tanks and all. So the normal personnel is, there are 2 only, but on this job, they had an extra personnel. So it was necessary to have total 5 people. So this provided, as I mentioned before, mostly they're just 1 cementer, but right now I think you've seen more than 2 or more than 1 personnel cementer in the rig now in Indonesia. But back then it was just 1, and now they have 5, and it means the 5 is they provided 2 groups of 2 people to operate the cement equipment in 4-hour shift, and a job supervisor, 1 job supervisor, maintain coordination with the bulk delivery, fluid delivery, liquid additives, because everything has to be continuity, right? Continuous. So yeah, and then it's big volume of additive. Like we use 10,000 gallon of the anti-gas migration additive, 2,000 gallon of dispersant, 2,000 gallon of, so it's like it's a 23 total of tanks on location for the job execution. All the equipment, all the pumps were changed. Everything has to be new. The biggest issue, I think if you're familiar, you will think about like how is it even possible with the bulk storage, right? Because the rig will have limitation on the bulk storage. So that especially if we are only using the dedicated one for cementing, right? So the bulk storage that we use for this job is the dedicated cementing one, plus we have to empty all the one that is usually used by mud company, and we use it for the cementing as well. So we were really stretching everything to the limit, yeah. So all the silo utilized on this one was in total of 12,000 cubic feet of cement silo, because we added the 8,000 cubic feet of storage coming from the mud company. Okay. Yeah, this is the job that Mbak Nisa is asking. And this is the job chart. So you can see we start pumping at 1-3 on the very top. I don't know if you see 1 p.m. right? And then we start pumping. So your green line, your green chart is your density, slurry density. Middle part, the blue one is your pumping rate, and then the red is the pressure, pumping pressure. Okay. And look how density is good, because it's also in the big scale, but it's basically it's good. It's they're pumping straight 12.5 ppg or 13 ppg slurry here. And so we start at 1 p.m. with the crew on 4-hour shift, and they finish at 1:30 a.m. in the morning pumping. Okay, so that's from cementing. I have more. Do we have question, or we can go to annular pressure buildup?
Okay, so there are a couple of questions coming. The first one from Bang Ihsan. How did you manage to mix and put the mixing fluid in advance for such huge slurry volume? When is the retardant mix?
Oh, okay. So in Deepwater, we don't usually mix the mixed fluid in the mixing tank. So we use liquid additive system. I think I have the picture. Equipment here. This is example of inline LAS. LAS is liquid additive system. So this system now there is the one that is direct injection, directly injected to your mixed fluid line, or there is one with a drop tank. So and you know, there is the one also now autonomous one where the concentration is also you input in the computer, and it's gonna go as per the input, or you go and see your metering and you drop it manually to the big tank of a mixed fluid. So it is connected to tot tanks. So we don't mix it in advance like we do in maybe in land operation or in the small jackup, right? So so everything has to be liquid. Otherwise, if we have a solid additive, then it's just going to complicate even more the operation, right? Because then you need to rehydrate it, you need to make sure it's mixed properly. So if everything is liquid and you keep your number of additives simple, just the minimum is the better, like just 4 or 3. If it's not necessary, don't even put, right? So you put very minimum, keep it simple, and then you use LAS, then it's possible. The retarder is also going to LAS because it's a continuous use, right? If you're talking about like a 100-barrel job in land operation where in total you only use like maybe 20 gallon of retarder, yes, you probably drop it into the mixing tank or in the, manually, right? But here it's just continuous and with the equipment, the right equipment.
Okay, thank you, Mbak Cinto, for the answer. And we also have another question from Luki, petroleum engineering student. So if loss circulation additives will be added to the cement slurry, do we also need to add filtration loss additives? Because if we lose the water filter to the borehole walls, we will lose the ability to transmit the hydrostatic pressure to cement in the lower part of the annulus. And the wellbore pressure will be reduced. Thank you.
Okay, so that's a good one. The filtration additive control or fluid loss, the technical term that we usually use is the fluid loss control. This is the additive that we added to the slurry to make sure that under downhole condition that the slurry will maintain the fluid in it, even though it's come to a permeable formation, it will not losing the fluid, while it's going to be hydrated completely, right? That's the fluid loss control. The low circulation material is different material. Is the one that we added to the slurry, most of the time they are inert, so they will not giving any chemical reaction or impacting anything chemically to your slurry properties. Like you can put flakes, fiber, so it's not going to impact your fluid loss level, for example. So it's not connected to each other. That's what you usually call as inert material. Okay.
Yeah.
Good question. Thank you, Luki. So now, just last two topics. This is about annular pressure buildup. Again, this is the unique phenomenon that's also only happened in Deepwater. Reason why this is there is because the the subsea wellhead equipment that is there in the subsea down underwater arrangement is having metal to metal seal. So everything at the subsea wellhead is sealed completely, and there is no possible way like in the surface operation or a regular land operation where we can bleed off the pressure in the annulus through the valve later on easily, right? So in the subsea wellhead, everything is metal to metal seal, which you cannot access. So, and having this in the wellhead, when we drill the well and then cement it up, there will be fluid trapped in the annulus, right? There will always be a risk of a fluid trapped in the annulus, having that fluid. Once the well is in production or in drilling, maybe the temperature will rise. This fluid will expose to some heat, that high heat, and will expand. When it's expanding, the pressure will find the easier path or the way to release it, right? Since we have a metal to metal seal at the wellhead, there is no other way for the pressure to release. In the end, it will resulting in the the casing collapse or burst, right? So in having this phenomenon in the water, in cementing the water, what do we usually do? We don't bring our top of cement to the previous casing shoe. So why? Because we want to always leave some formation exposed or open formation. So in case there is an annular pressure built up, the weakest point will be the formation, and then we will go there instead of collapsing your pipe, your casing, right? So because there's no other way because of the seal on the top. So yeah, so make sure that you don't design your casing, your cement up to the previous casing. if there's no sand to cover on the top, if your job objective of the cementing is just to get a good shoe, 300 meter, 100, 200 meter of good shoe, cement around the shoe, that's good enough. You know, there's no need, again, the water operation, make it as simple as possible because it's already complicated. A small volume enough for securing your shoe, that's good enough, right? So that's from mitigation plan from cementing, but there is another way that the operator can take, you know, to mitigate. For example, hold on. There's your pressure. Yeah, for this is the APB. This is what happened to your casing when it's collapsed during the if we have APB during circulation. This is one example. They have to pull it out to surface. This is another mitigation plan that they can do. Let's say that you do have some sand layer very close to the previous shoe, and you need to put concrete there. You need to cement it up for the well integrity, right? So what can you do for the mitigating APB if it happen in the future? You can put the burst disc. You can also pump some foam spacer. You know, there's so many things that the you know, the operator can also do, and take this in mind, and you know, plan this ahead instead of, you know, later on you cannot you know, provide the correct mitigation plan and then have the casing collapse. From fluid, as I mentioned, another mitigation plan, you can pump the foam spacer, you know, just to give its way to expand, to be compressed, because, you know, a foam spacer is compressible. Okay. So that's the APB, again, unique one that we can we found only in Deepwater also. So last one is it's about any question right now, Rahmi, or?
There's a question, follow-up question actually from Bang Isan. So, but relating to the previous slides or presentation, is the cementing unit and pump specification different between the conventional offshore and deep water?
It's very broad question. Usually it is a standard, you know, it's always double pump, double engine, because you always want to have that redundancy, right? Offshore is also remote. It's not like you going to DSF in 2 hours, you can get another pump as a backup, you know? So always have a redundancy. So offshore is also important to have a good cement unit. The difference is usually the cement unit what do you call it, specification, it has to be in the same level as your rig specification. So if your rig is capable of drilling 10,000 feet water depth with 10,000 feet of first section with 12,000 cubic feet of bulk capacity, then your cement unit will have to be also the same competent level, right? So this something like that. So and then this usually comes with this requirement usually comes from the rig company as well, or how the service provider would want to match their rig capacity, right? So I think that's how I can answer that. Yeah.
Yeah. Thank you, Mbak. And another question, follow-up question from Luki. Just a quick response to these two types of additives, the low circulation material and filtration loss materials is not used simultaneously.
It's not apa, Rahmi?
Do these two types of additives, I believe he mentions the filtration loss materials and the low circulation additives, are they not used simultaneously?
Oh, they can be used at the same time, at the same slurry, yes. I'm just saying that because low circulation material that we put in the slurry, it could be inert. If it's not inert, then it's not going to. I'm just saying that it won't affecting fluid loss control, right? Because the method or the how it works on the LCM, on the low circulation material in the slurry, will be a different method on the fluid loss. So it is used simultaneously on the same slurry, but it won't affecting or giving bad bad result with each other. Definitely, the service provider has to make sure that it is followed. It is not going to ruin each other. Okay, so last one, this is about compliance. So we talked about it during the Q&A before. So when I mentioned, after the Macondo, this API standard, used to be API RP 65-2, which is a recommended procedure. After the Macondo, they form a committee consists of so many different experts from different company, different background in cementing expert, and then they standardize and then make it standard, and they improve the contents, right? So everything is a must now. So they went through again. So it's a very signifies that the cementing committee's attempt and all effort was on the table to take into account all the lessons learned that we got from the Macondo incident and take steps to limit exposure in these areas going forward, right? It is the objective of this guideline is first to help and prevent and or control the flow just prior to, during, and after cement job. And then what else? So it is, okay, I think we all know it is mainly used in Gulf of Mexico, but I think everyone is using API standard, right? I wanted to show different standard. It's not just API standard 65. There are many different API RPs and also standard, also related to deep water. So this, like for example, the API RP 96. This is deep water well design consideration. We'll identify consideration for use in the water well design. There is API 10B-3. This is about testing of well cement use in the water well construction. So this is all detail about how we should test the cement slurry for deep water purpose. And it's very thorough, very detailed. If you want, I mean, for me, if you want to start something, your deep water operation, you just learn, or you want to know basically what the slurry requirement should be, go and open this. You'll see, you get all the information there. Therefore, you can challenge the service provider as well. And then there are two API RP that I put here, IP 90 and 90-2. This is all related to SCP, ACP, annular casing pressure, and which is including the sustained casing pressure, or what we usually call SCP. Okay. So one is for offshore, the other one is for onshore. In APIs, yeah.
No, kindly reminder that we have remaining 10 minutes.
Okay. So just quickly, in the API standard 65-2, it has best practices for zonal isolation. It's not just all about cementing. So you can see guidelines on hole quality, drilling fluid, what you should be in the drilling fluid, about the casing hardware, wellbore preparation, cement job execution, the post-cementing operation. Okay, so yeah, this is also a very good guideline if you want to, to assess the job that you are designing right now. We want to take all into consideration all the points when designing the job, the water job. Go and also check this one. It has very critical, very detailed critical cementing fluid parameters. So very good information. Yeah, that's all. My last slide is about subsea head. There's so many available now in the market. They, along with the rig capacity, they also increasing, all the service provider, they also stretching and increasing the limit of the capacity of the subsea head in terms of the hook load capacity, the maximum circulating rate, all of those. So, and then everything now is also remote control. Some of them are even wireless control. So you have an iPad where you punch button, then your dart will release. So, and it's just wireless. So it's very, very cool, and it's available in the market. That's my last one, Rahmi.
Thank you, Mbak Cinto. That was such an interesting and informational presentation. We have a few last minutes. If anyone has any questions, you can type it on the chat box, or you can raise your questions. Yeah, you can raise your questions. Actually, Mbak Cinto, it was a very interesting presentation, including the APB. You mentioned that the APB could happen during circulation. I thought that was only after the post-cement job. So how did that happen, actually?
Hold on, I lost you.
Oh, okay. Sorry.
No, hold on. How do I get back? No, I cannot see. Oh, I'm still sharing.
You're still sharing your screen, but yeah.
Okay. I don't know. It's okay. I cannot see. Okay, so how so let's go back to that slide. Let me see. Here, right? APB. Yeah, see this. So during circulation, how did it happen? Oh, no. Okay, Rami. It happened only after you cemented because there is no other way, or unless also if the formation is very strong that it cannot. If it's very strong, it's not flexible, then it's just going to put the pressure towards the casing, right? So this example that you're talking about during circulation, it could be also what happened. This is not cemented. Definitely, that's why they can pull it out, right? So in this case, then definitely your mitigation plan has to be that burst this. So I believe this is something related to the probably your somehow your fluid, because of the temperature rise, the fluid get expanded and then it's just burst in here because there's no way up going up there, right? So I think so. Definitely, this is what your question, right? Because they managed to pull out, so definitely it happened before cementing job. That's right. You're right. Yeah.
Okay, thank you. And I think we've come to the end of our session today. So ladies and gentlemen, thank you so much for your active participation, and especially thank you to our honorable speaker today, Mbak Cinto Azwar. Hopefully the session today would be beneficial for everyone. So by the end of this session, let's take a picture together to capture the moment today. So everyone, if you could please turn on your camera.
Someone is joining from the rig. Pak Ferdiansyah.
Okay. But Ian, can you help us to?
Yes,
Okay.
I'll take a picture now, yes? Okay, be ready. 1, 2, 3, cheers.
Tunggu Mbak, Pak Prijo nih masih. Nah,
Okay. I'll
Lagi.
repeat ya.
soalnya ada effort.
Pak Priyo.
Ayolah.
Okay, ready?
Ya,
Okay, 1, 2. Okay, some more people is still turning on the camera. Maybe we wait a little bit, yeah?
Yeah, sure.
Let's give a chance for everyone to turn on the camera.
dari rig mana nih Pak Ferdiansyah?
Saya di Katarina, Ibu.
Oh, aduh. Lagi di mana ya Katarina ya?
Stuck lagi di Anchorage, Balikpapan.
Oh, oke. Keren itu
Oke.
Pak main unitnya.
So kita ini ya,
Ada internet
take
loh.
picture sekarang ya. Oke, getting ready. 1, 2, 3, cheers. Okay, wait a sec. Another panel. Okay, I think that's all.
Mbak
Alright,
Dian, do you
thank
need help?
you.
Alright, done,
I
yeah,
cannot
okay.
see the other panel. Isan, maybe you can check if I miss another panel. I cannot see another panel. One more, yeah, guys.
Yeah.
Yeah. Okay. 1, 2, 3.
Cheers.
Cheers. Okay. 1, 2, 3. Cheers. Hold your smile. Thank you all.
Thank you.
Thank you.
So before everyone goes, we have a last token of appreciation that will be given to Mbak Cinto ya. Mbak Nisa, I give the floor to you ya.
Okay. Thank you, Mbak Cinto, for this a good presentation. We learned a lot during these 2 hours. So hopefully this is also useful for all the members to learn about the drilling, deepwater drilling, and hopefully in Indonesia it will be another drilling, deepwater drilling in the future. So on behalf of the SPE, I would like to hand it over to you since you are above me. So I just give it to you like this. The token appreciation, and it will be, since we are also online, it will be sent also through the air to your email box. On behalf of the SPE and TDG session and also DNI committee, I would like to say thank you very much.
Thank you, Mbak Nisa.
So let's take a picture first ya, Mbak Cinto, Mbak Nisa with the certificate. Ihsan bisa tolong ya?
Yeah, sure. Okay.
You spotlight both.
The certificate is in your right side, but it's okay lah. No, it's okay. To pause. Okay. I'll count 1, 2, 3. Smile. 1, 2, 3. Smile. Perfect. Thank you.
Thank you very much. So thank you again, Mbak Cinto, Mbak Nisa, and Mbak Rahmi ya, for a great session today. Hopefully the attendants, the participants can gain useful knowledge for themselves. Yeah. So for the participants, please provide us feedbacks, especially if you require a certificate. Please fill in the evaluation form in this bit.ly link. Yeah, you can also access it in the chat box. I already post the link there. And please provide us feedback, share improvement. So this is the end. This marks the end of our session. For future events, please follow us on social media. We will also communicate through email from the SPE Java if there's any events coming up. All right. Okay, thank you very much. Have a good day, remaining of the day, and have a good weekend ahead. Thank you. Hope you can join our future event.
Thank you. Bye-bye.
Thank you, Dian.
Bye.
Thank you, Mbak
Rahmi,
Cinto.
Mbak Nisa.
Thank you, Mbak Cinto, Mbak Rahmi,
Oh
Mbak
ya,
Nisa.
Iksan. Thank you
Makasih
ya.
semua.
Bye.
Sampai ketemu.